Hello, y'all. Welcome to lesson 72 of my DP chemistry curriculum. Today we're doing reactivity 1.3.1. We're going to talk about reactive metals, nonmetals, and organic compounds, how they undergo combustion reactions when heated in oxygen. We'll deduce the equations for reactions of combustion, including hydrocarbons and alcohols. So, combustion, what the heck is it? Most of us think about it as fire, which is mostly accurate most of the time, but really the more complete definition is a reaction involving fuel and O2, usually in the gaseous state, oxygen. Another thing about combustion to note is it's always exothermic. It's one of the few types of reactions that will always be exothermic. And remember, that means delta H is going to be less than 0. It is always going to be a negative delta H value. The enthalpy will always be lower. Our products are always more stable. Products more stable than reactants. So, as we also mentioned before, that it is a reaction that happens when we heat in oxygen. So we need initial heat source. All right, so that's combustion. But we're going to go over three types of combustion today. Let's start out with metal combustion. When you take a metal and we combust it with oxygen, we end with a metallic oxide. So we're always going to form a metallic oxide. It'll change depending on the metal. A couple things of note is that alkali metals, meaning the first group of the periodic table, so lithium, sodium, potassium, cesium, all those, alkali metals are the most reactive, followed by then alkaline earth metals. Those are still very reactive. When we have these react with oxygen in a combustion reaction, we always get a couple products, or I mean, we always know we're going to get a metallic oxide, but they also produce heat and light. Heat and light. Now, we do have less reactive metals that can react with oxygen, but it's a little different. So, less reactive metals, these do what we call rusting or tarnishing. As their iron rusts, you get iron, which becomes Fe2O3. This is traditionally what we think of as rust. Copper can be Cu, turns into Cu2O or CuO, cuprous or cupric oxide. Silver often becomes Ag2O. So this is what we say when things develop a patina, like the Statue of Liberty turns blue. Silver instruments kind of turn that brownish color over time. Rust is red, brown, orangey color. So this is still technically combustion. It is a less energetic and very slow combustion reaction. So this is what I mean by it doesn't always have to be fire. But the key thing is that our delta H is still negative. It's still going to be less than 0. And it is still producing this metallic oxide. So that's metal combustion. Next, we're going to go on to non-metal combustion. It's very similar in the start. Instead of a metallic oxide, our non-metal plus oxygen will usually produce a non-metal oxide. Non-metallic oxide. So metals make metal oxides, non-metals make non-metallic oxides. Pretty simple. Now, the thing is, Unlike metals, these are not in fixed ratios. So with metals, we can generally figure out the ratio, like magnesium forms a 2 plus charge, so it'll be MgO. Sodium forms a 1 plus charge, so it'll be Na2O. But these are not fixed ratios. That's because nonmetallics or nonmetals covalently bond. Covalently bond. Not ionic, like our metals. This means that we can have many different combinations. If we take phosphorus and react it with 5 oxygen versus phosphorus and react it with 3 oxygen, we'll get 2 different products. Both will be very exothermic, but we might get P4O10 or P4O6. These are different forms and different compounds, and that's based on the fact that these are covalent bonded structures. So it may not be as simple as a ratio. That is non-metal oxides. All right, the last one are, I was going to say hydrocarbon, but what I mean to say is organic combustion. This is the combustion that most of us are familiar with on our daily basis, daily lives. This is usually with hydrocarbons or alcohols. So if you think about like gasoline or a candle or rubbing alcohol or any of that stuff, that flammability, that fire is organic combustion. So organic combustion usually is carbon, hydrogen, and oxygen. And so CXHYOZ, these can be zero as well. So it can just be like carbon and hydrogen, no oxygen, plus O2 reacts to form H2O plus CO2. We're always going to get water, and most of the time we're going to get carbon dioxide as well. And of course, it's always exothermic. So just an example of an alcohol and a non-alcohol, we can take methane plus oxygen, and we're going to get H2O plus CO2. And we can balance this very quickly. We can recognize that we have 1 carbon and 1 carbon. We have 2 oxygen, and we have, oh, not enough. So we're going to put a big 2 there. We'll put a 2 right there. And so now we have a fully balanced hydrocarbon combustion. We can do the same thing by replacing this with maybe ethanol. C2, or actually I'll write it out, CH3, CH2OH plus O2 reacts to form H2O plus CO2, liquid, gas, liquid, gas. And in this case, we have 2 carbons, so I'm going to go ahead and double the carbon in CO2. I notice I have quite a weird number of oxygens. I have 1, 2, 3, and then I have 3 hydrogens plus 2 hydrogens plus 1 hydrogen. That's 3 hydrogens. I'll put a big 3 here to match our 6 on each side. I notice I have 3 oxygens plus 4 oxygens for 4 oxygens for a total of, whoops, 7 oxygens. I've got 1 right here, so I'll just put a 3, and we have a balanced chemical reaction. This is probably the most common type of reaction you're going to be doing when you're talking about combustion. The IB will fully expect you to combust hydrocarbons and balance those out. Anyways, I hope this helps introduce you to combustion. Next time we'll talk about incomplete combustion, and have a great day.